Multiplying integers, lesson 2-7. The mastery objective for the day was that students will be able to use an equation mat to multiply integers. Now, as a general rule, we came up with the product of two integers with the same sign will be positive. The product of two integers with different signs will be negative. Now, many students are capable of memorizing these two rules here. However, it proves to be more of a challenge if they explain why these rules work. This is where equation mats become handy. Taking a look at the original equation of y equals 3 times negative 2, we want to go ahead and model this to represent again, or to prove why the idea of the signs being different will equal a negative number. So let's begin by using our equation mat here. Now, looking at the original equation of y equals 3 times negative 2, this is telling us that 3 means that we're going to put 3 sets of counters on the mat. The negative 2 means that each set contains 2 negative counters. So overall, we're going to create 3 sets of negative 2 counters. So if I look at this now, I am now having the 3 sets, 1 set, 2 set, and finally my third set of negative 2 counter each. I place those counters onto the mat, and that leaves me with a total of 6 negative counters. Now, taking a look at a new equation, I see that z equals negative 2 times negative 5. Again, we're going to begin with our equation map. Now, or mat. With our equation mat, it is now empty, but the original equation tells me I must take negative 2, or remove 2 sets of counters from the mat. The negative 5 means that each set contains 5 negative counters. Well, right now I have nothing on the mat, so therefore I cannot remove 2 sets of negative 5 because there's nothing there. Instead, since the mat has no counters, I must add 0 pairs until I can visually represent the negative 2 group, or remove 2 groups of negative 5. What that means is now I'm adding enough 0 pairs to represent one group of 5 and another group of 5 over here. When I place them on the mat, that now gives me a visual opportunity to go ahead and remove then the 2 sets of negative 5 counters. So once those zeros, or additive inverse, or 0 pairs are placed on the equation mat, I can now remove 2 groups of negative 5. And that goes back to the original equation right here, where we are removing 2 sets of negative 5. Now that I've been able to go ahead and represent that with my 0 pairs, I can remove the negative 5 right here and the negative 5, which will give me my 2 sets of negative 5 being removed. What's left on the mat are the yellow counters, which are 10 positive counters. So again, z equals negative 2 times negative 5, and in the end, z equals positive 10.